household bleach is an oxidizing agent that contains sodium hypochlorite NaOCl as the active ingredient. It reacts with the iodide ions in acidic solution as follows. A 10 cm³ sample of bleach was reacted with a solution of excess iodide ions, and the liberated iodine was then titrated with sodium thiosulfate. The titration requires 38.65 cm³ of 0.0200 mole per dm³ of sodium thiosulfate. Determine the concentration of OCl bleach, OCl minus in the bleach. So that's a question mark. So we have both equations given. So we can see in the first equation, iodide ions, they react with ClO minus. So the iodide ions, they are in excess, and iodine is liberated. And that liberated iodine is titrated in the second step with sodium thiosulfate. We have been given the volume of sodium thiosulfate and the concentration of sodium thiosulfate. So straight away we can find out the moles of sodium thiosulfate. So N of S₂O₃², and mole is equal to concentration times volume. Volume has to be in dm³. So concentration is 0.0200, volume is 38.65 divided by 1000. So we will have moles of sodium thiosulfate. So if I solve this, that will give me 7.73 times 10 to the power minus 4 moles. Next we need to find out the moles of iodine. So the moles of iodine, N of iodine will be equal to 7.73 times 10 to the power minus 4 divided by 2, because the ratio between sodium thiosulfate to iodine is 2:1. So if I solve this, that will give me 3.865 times 10 to the power minus 4 moles of iodine. So iodine is produced in the first step, and how much iodine is produced, it depends on ClO minus, because that is a limiting reactant. Iodide is in excess, so the ratio is 1:1. Hence the moles of ClO minus will be, so the mole of ClO minus will be equal to moles of iodine. So ratio is 1:1. So we can say N of ClO minus will be equal to 3.865 times 10 to the power minus 4. Next we need to find out the concentration. So determine the concentration of OCl minus in the bleach. So concentration is equal to moles over volume. Volume has to be in dm³. So 3.86 times 10 to the power minus 4, and the volume we started with is 10. So divided by 10 over 1000. If I solve this, that will give me 0.0387 mole per dm³.